Hello learners, I am Abhijit Lal, Assistant Professor, Department of EEE, Bhilai Institute of Technology, Durg. Today we are going to study about the need for rectification and rectifier parameters. These are the contents which we are going to study, that is need for rectification, then what is a rectifier, types of rectifier and application of rectifier. Now what is the need of rectification? Process of converting AC voltage into DC voltage is called rectification. A DC supply is an important element of any electronic circuit. In daily life, we are using a number of electronic devices which operate partly or fully on DC power supply. Due to economics of generation and transmission, the electric power available is usually an AC supply. So let's see this picture. A DC power supply consists of various stages. As we all know, the power generation is done in AC because in AC the voltage can be step up and step down very easily by a device called transformer. That is why in most of the cases and mostly the power generation is done in AC. So to use this electricity as DC, first we have to convert this AC into DC, and for that only rectification process is used. And as we have studied, the rectification is the process of converting AC signal into DC signal. So from this figure we can see that to obtain a DC supply, the following process takes place. So first one is the input, which is the AC mains. Suppose the supply is single phase, so the voltage will be 230 volt and the frequency will be 50 hertz. So the AC signal is given to the transformer, where transformer it steps down or step up the voltage according to the requirement, and in most of the cases it is step down, because the DC voltage which is used in electronic circuits is either 5 volt or 12 volt. So mostly the transformers used are step down transformers. So the AC signal is stepped down by using a transformer. Then the second device is the rectifier circuit. The secondary winding gives the step down voltage, and that is given as an input to the rectifier circuit. Now the rectifier circuit converts this AC signal into DC signal. As we can see in the figure, when the rectifier is converting this AC into DC, the DC obtained is not pure DC, but it contains some ripples. So that is why this type of DC signals is called as pulsating DC. So to obtain a pure DC, the output of the rectifier circuit is given to the filter circuit. Now the work of filter circuit is to remove the ripples from the DC obtained from rectifier circuit. So after the filter circuit, the DC signal is given to the regulator circuit. Now the purpose of regulator circuit is to regulate the DC according to the requirement. The amount of voltage required for the DC is regulated by the regulator circuit, and final output of the regular circuit will give the smooth DC supply. So this is the process by which we can obtain a DC power supply. So let's understand all this process in more detail. So the single phase AC voltage, that is 230 volt or 50 hertz, is connected to the primary winding of the transformer, where transformer steps down the AC voltage to the desired level of DC output. The output of the transformer, that is secondary AC voltage, is given to the rectifier circuit, where it converts AC voltage into pulsating DC voltage. A pulsating DC voltage means a unidirectional voltage containing large varying component called ripple in it. So the pulsating means a DC, but which is having a pulsating components. That is why it is called as ripple. Pulsating components are called as ripple. So that is why it is called as pulsating DC. Now the output of rectifier circuit is given to filter circuit, which reduces the ripple content in the pulsating DC and tries to make it smoother. The voltage obtained from the output of filter still contains some ripple. and this is called unregulated DC voltage. The unregulated DC is given to a regulator circuit which makes the DC voltage smooth and almost ripple free. The output of a regulator is called DC supply, to which load can be connected. A regulator keeps the output DC voltage constant irrespective of the source voltage and load conditions. Here one thing is important about the working of regulator is that even if the input or the source side voltage is changing, but the output of the regulator will be a constant value. An example for this voltage regulator is the normal voltage regulator which we use at our homes for air conditioners or for refrigerators. What it does is that it regulates the voltage, although that regulator is an AC regulator, but the purpose of the regulator is that even if the source side voltage keeps on changing, but the output of that regulator will be constant. And similarly, even if the load side the parameters will be changed, the voltage remains constant. Now let us study about the rectifier. So what is rectifier? A rectifier is a device which converts AC voltage to pulsating DC voltage. This process of converting alternating current AC to direct current DC is also called as rectification. Now in this figure you can see when the input given to the rectifier is AC. AC means bidirectional current. It is having a bidirectional current, that means it has a positive half as well as a negative half. When AC signal is given to rectifier, it will give output which is having a unidirectional current. That means the current which is having the output in only one phase, but it is not pure DC. As we have studied, it contains some pulsating components which is called as ripples. That is why it is called as pulsating DC. So for the rectification process, different semiconductor devices can be used, that is diode, thyristor, etc. So here in this lecture we are going to study about the rectifier which is based on diode. That means the semiconductor device which is used for rectification will be diode. Now let us study about PN junction diode rectifier. The PN junction conducts only in one direction, that is when it is forward biased. When an alternating voltage is applied across PN junction diode, diode will be forward biased during positive half cycle and will conduct successfully. As seen in the below figure, when an AC signal is given to the diode, we obtain a DC output. Although the DC seen here is a constant magnitude, but this output will be after the filter and then the regulator. That final output after the regulator will be the direct current, that is a smooth direct current or smooth DC output. During negative half cycle, the diode will be reverse biased and will not conduct at all. Conduction occurs only in positive half cycle. If the resistance is connected in series with the diode, the output voltage across the resistance will be unidirectional, that is DC. Here the word unidirectional means the output will be in any one of the phases. It will not on the both side of the axis. That is why it is called as unidirectional. Thus, PN junction diode subjected to an AC voltage acts as a rectifier, converting alternating voltage to a pulsating DC voltage. That means a simple diode, a single simple diode can be used for a rectification process. That means as we have studied in the previous lectures also, the semiconductor diode allows the current in one direction only and it blocks the current in the opposite direction. So this principle works here for the rectification. So PN junction diode subjected to an AC voltage acts as a rectifier, converting the alternating voltage to a pulsating DC voltage. Now the important points to be studied while analyzing rectifier circuits. First, waveform of the load current. So when we are studying about the rectifier circuit, and in the future lectures, in the coming lectures, we are going to study different type of rectifiers. So, to analyze that rectifier circuits, various parameters should be known. So, first one is the waveform of the load current. Now, here the waveform of the load current is very important, as the nature of the current through load determines the waveform of the load voltage. It means, depending upon the type of load connected with the semiconductor device or connected with the rectifier circuit, the waveform of the load current changes. For example, suppose the load is pure resistive load, the waveform of the current will be same as that of the voltage, whereas when the load changes to RL or suppose it is L, the waveform of the load current will change, and similarly for RLC load and so on. So, this line means the nature of the current through the load determines the waveform of the load voltage. Second parameter is regulation of the output voltage. Practically, the load voltage should remain constant, but when the load current changes, the load voltage also changes. So, the regulation tells the effect of change in load current on the load voltage. It means, when the rectifier is working at certain load, it will give a certain amount of voltage, a magnitude of voltage, but as soon as the load changes, the voltage at the output of the rectifier will also change. So, the regulation means, a regulation of the output voltage means it tells about the change in the output voltage when the load changes. And then the next parameter is rectifier efficiency. It tells how efficiently the rectifier circuit converts AC power into DC power. Next is peak value of current in the rectifier circuit. It is the maximum value of an alternating current in the rectifier circuit. This decides the rating of the rectifier circuit element, which is diode. So, this parameter is very much important, as the diode is connected in a rectifier circuit. Diode is used as a rectification in rectification circuit. So, the value of peak current should not exceed the maximum current rating of diode, otherwise it may damage the diode. So, peak value of current in the rectifier circuit should be known. Next parameter is ripple factor. So, what is ripple factor? The output of the rectifier is of pulsating DC type. The amount of AC content in the output can be mathematically expressed by a factor called ripple factor. So, ripple factor will tell us the amount of AC content, that is the pulsating component present in the DC output. Next parameter is peak inverse voltage, which is also called as PIV. It is the peak value of voltage across the rectifier element in the reverse direction. When the diode is not conducting, the reverse voltage gets applied across the diode, and the peak value of such voltage decides the peak inverse voltage, that is PIV rating of the diode. As we all know, the diode blocks the current in the opposite direction, or we can say that when the diode is reverse bias, very small amount of current, which is the leakage current, flows through it, and it is said that the voltage in the reverse direction should not exceed to the amount such that the avalanche breakdown takes place. So, it is very important the amount of voltage which is given in the reverse direction. So, PIV or the peak inverse voltage is the parameter which tells about the voltage which is applied in the reverse direction to the diode. Next parameter is transformer utilization factor. This factor indicates how much is the utilization of the transformer in the circuit. As we have seen, for the conversion of AC to DC, the process involves the use of transformer. That means, the AC voltage is stepped down, then it is given to the rectifier circuit, and from that the AC is converted into DC. So, the transformer utilization factor indicates how much is the utilization of the transformer in the circuit. It is defined as the ratio of DC power delivered to the load to the AC power rating of the transformer. That means, the amount of power which is given by the rectifier circuit, or which is delivered to the load connected with the rectifier circuit, divided by the AC power rating. Now here the AC power rating means this rating of the secondary side of the transformer, because the secondary voltage is given to the rectifier circuit. So the AC power rating of the transformer is taken in the denominator. Now let's study about the types of rectifier. The rectifier are basically of two types, that is half wave rectifier and full wave rectifier. In half wave rectifier, a single diode is used for rectification and it gives output in only one half, whereas in full wave rectifier we will get the output in both the halves. That means for positive half of AC and for the negative half of AC we will get the output as DC. Now from this figure we can see that the full wave rectifier are of two types, that is first is center tapped type full wave rectifier and second is bridge rectifier. Now what is the basic difference between this? In center tapped type full wave rectifier only two diodes are used. So one diode works for the positive half of AC and another diode works during the negative half of AC. Whereas in bridge type of rectifier, four diodes are used and they are connected in the fashion which is called as a bridge, and from there the name is derived, which is called as bridge rectifier. So about this half wave rectifier, full wave rectifier and bridge rectifier we are going to study in detail in the coming lectures. Now let us study something about the application of rectifier. Now this part is very important because we used to hear about the rectifier most of the times, and rectifiers are used very widely in most of the applications. So it is very important to understand the application of the rectifier. So one by one we will see the applications of different type of rectifiers in different fields. So let's start with the uses of half wave rectifiers. Some important uses of half wave rectifier are listed below. First one is modulation, for the purpose of modulation. So what is modulation? A modulated signal contains information to be communicated. When this signal is applied to a carrier signal to change its features, the process is known as modulation. So in communication, modulation is a very important process in which a modulated signal is used as a carrier signal. So when this signal is applied to a carrier signal to change its features, the process is called as the modulation. So rectifiers are used for and specifically the half wave rectifiers are used in modulation purpose. So amplitude modulated communications can be demodulated using a basic half wave diode rectifier. So for the communication purposes, the amplitude modulation is done, and where the half wave rectifiers are generally used. Next application is for voltage multiplier. A voltage multiplier is an electrical circuit that transforms AC electrical power from a lower voltage to a higher DC voltage. The voltage multiplier is made using a half wave rectifier. So in many circuits the voltage needs to be multiplied, or it needs to be step up, that means the DC voltage. So for that voltage multiplier is used, and for the purpose of voltage multiplier this half wave rectifiers are generally used. Next application of half wave rectifier is for soldering. The circuits that require a soldering iron use a half wave rectifier. Metal pieces are joined using the soldering technique to create an electrical link. As we all know, soldering is a very important process for process in electronic circuits. So in the soldering circuits the rectifier half wave rectifiers are used. Next one is transformers. We can use step down or step up transformers in combination with a half wave rectifier to generate the appropriate DC voltage. A transformer is a passive part that transfers electrical energy between circuits, whether they are single circuits or multiple circuits. Step up transformers are transformers created to increase the voltage from primary to secondary, whereas the step down transformers are transformers created to decrease the voltage from primary to secondary. Last applications is in various circuits. So, half wave rectifier is used in firing circuits and circuits that produce pulses. Now, here a special type of circuit is defined, that is called as firing circuit or the circuit that produces pulses. Now, what is firing circuit? As we know, in modern semiconductor devices like thyristors, MOSFETs or IGBTs, the gate pulse is required, or specifically when I talk about thyristor, a gate pulse is required to switch on the thyristor. So, the gate pulse or the gate signal is provided by a circuit which is called as firing circuit. So, the purpose of firing circuit is to give pulses to the firing element or the firing terminals, which is the gate in modern semiconductor devices. Now, let us study something about the uses of full wave rectifier. Some of the main uses of a full wave rectifier are as follows. So, the first use of full wave rectifier is for power supply. Full wave rectifiers are extensively used in power supply circuits to convert AC power from the mains into a smoother DC output. So, with the application of the power supplies, the full wave rectifiers are used. Second application is for battery charging. Full wave rectifiers are employed in battery chargers to convert AC power into DC power for charging batteries. So, the important example for this is the mobile phone charger. Here we use the charger and we connect it to the AC supply, and we used to charge our mobile which is having a battery, and battery works on DC. So, that charger consists of a rectifier, and basically that rectifier is a full wave rectifier. So, for wherever the battery charging is required or continuous power is required to charge a battery, a full wave rectifier is used. And the another example for the battery charging is in the EVs. Nowadays, the rise of EVs is going a lot. So, that is why the battery charging circuits requires a full wave rectifiers, so that the battery charge in a very smooth manner. So, for that application full wave rectifiers are used. Next application is for the motor control. The full wave rectifiers are used in motor control circuits to convert AC power into DC power for driving motors. Now, the example for this is that suppose you have to run a DC motor and the supply required and the supply available is AC. So, first we have to convert that AC into DC to run our motor. So, for this the full wave rectifiers are used. They convert the AC signal into DC signal, and with the help of the regulator desired voltage is obtained, and that is used for to drive the motors and certainly for the controlling purposes also. Next application of full wave rectifier is for welding equipment. Full wave rectifiers are utilized in welding machines to convert the AC power supply into a DC welding current. Next application is audio amplifiers. Full wave rectifiers are employed in audio amplifier circuits to convert the AC audio signal into a DC signal for biasing purposes. Next application is signal demodulation. The full wave rectifiers are used in communication systems to demodulate amplitude modulated signals. Now, here again the demodulation process comes into picture, which is a very important part in communication systems. So, in this communication systems full wave rectifiers are again used to demodulate or modulate or demodulate the system signals. So, full wave rectifiers as well as the half wave rectifiers, as we have seen in the previous topic, that is uses of half wave rectifiers. We have seen both type of rectifiers are used in the communication systems for the modulation purposes. Now let us study about the uses of bridge rectifier. Now as we have seen in the types of rectifiers, bridge rectifier is nothing but the full wave rectifier, but the construction, or we can say that the circuit construction is different for the bridge rectifier from the center tap type of rectifier. So bridge rectifier has specifically different type of applications. So let us discuss in detail about that. Below are some uses of a bridge rectifier. First application is in electric welding. First is the bridge rectifier circuits are used to provide constant and polarized DC power to electric welding. As we all know, in electric welding, a constant power is required. So for that, bridge rectifiers are used, and along with that the regulators can be used so that a constant DC voltage can be obtained, and a polarized, that means of us same polarity, that means it should be a constant value. So for that electric welding application, the bridge rectifiers are used. Next application is in different kinds of circuits, that is bridge rectifiers which can transform high voltage to low DC voltage are commonly utilized in large appliances. Every charger circuit which converts AC to DC consists of rectifiers. So as we have discussed in the full wave rectifier, that is the center type of rectifiers, the bridge rectifiers are also used in the charging circuits. So the for the conversion of AC to DC, for charging applications, for the firing circuits, the bridge rectifiers are also used. So depending upon the application, depending upon the requirement of the DC or the type of DC or the amount of the DC voltage or the output required, the bridge type of rectifiers or the center type of rectifiers are used for different applications. Next application is audio systems. So the bridge rectifiers are utilized in audio systems including amplifiers and audio power supplies. As you all know, the amplifiers are used to amplify the sound signals. So or we can say that in audio systems the rectifiers are used for the audio systems to amplify to amplifying purposes. So including amplifiers and audio power supplies, these bridge rectifiers are widely used. Next application is the lighting system. The bridge rectifier are used in lighting applications where AC power needs to be converted into DC power. Now some lighting systems are such that they works on DC supply. So because their working process is different, and maybe they are having a very high power rating. So for that, in such cases, that lighting systems consist of a rectifier circuit, so that even if the supply system is AC, so that rectifier converts the AC signal into DC signal, and from that DC signal or the DC supply, the lighting systems can run, or the lighting purpose can be fulfilled. So in most of the cases for the high power ratings, the lighting systems, the DC supply is used. So with such systems, such lighting systems consist of bridge rectifiers with them, so that even if the supply is AC, they convert that AC power to convert it into DC, so that it can give power to the lighting system. The next application is in the power electronic circuits. So the bridge rectifiers find widespread use in various power electronic systems such as inverters, uninterruptible power supplies, which is also called as UPS, and motor drives. Now the power electronics devices means the electronic circuits which works on high power ratings. That means it is called as power electronics and not electronics, because the power level is in the range of kilovolts and the current rating is in the range of kiloamperes. So the bridge rectifiers are used with the power electronic systems. Here the power electronic systems given mentioned is the UPS, that is we all know with the computer system we use a device which is called as UPS, that is uninterruptible power supply. So even if the supply gets off, it will give the supply, it keeps the supply on for certain duration. So for that system the bridge rectifiers are used. As we all know, inverter is a device which converts DC to AC. So in that system where the inverters are used, basically with the batteries, the bridge rectifiers are used. And lastly, with the motor drives, as we all know, there are different types of motor drives, that is AC motor drives, DC motor drives, depending upon the applications. In AC also we have the induction motor drives, synchronous motor drives. So in drives, the applications are for the starting purpose, for the braking purpose, for the speed control of the motor drives. So for all these applications, the bridge rectifiers are used to give the desired output. Suppose for let's take an example of a DC motor. If we have to run a DC motor or we have to use a DC drive, the supplies of AC can be converted into DC by using the bridge rectifiers. So these are all the applications of the rectifiers, and that is why this makes the application of rectifier the applications of due to all these applications of rectifiers, it is very important to study the different types of rectifiers. So in the coming lectures we are going to study the different type of rectifiers separately, that is half wave rectifier, the full wave rectifier, that is the center tap type, and the bridge type of rectifier. So let us quickly summarize what we have studied in today's lecture. So first we have seen what is rectification, the process of converting AC to DC. Which device is used for the rectification? It is called as rectifier. So we have studied about the rectifier. It is a device or a circuit which converts AC signal into DC signal. Then we have studied about the types of rectifiers, and that is half wave rectifier, full wave rectifier, and bridge rectifier. And after that we have seen the different applications of rectifiers. As we all know, the rectifiers are widely used in all the electrical circuits and all the electronic circuits. So it makes it very important for the study of these rectifiers. And basically the working depends upon the power level also. So where the half wave rectifiers is used, where the full wave rectifiers can be used, and in that also, in the full wave rectifiers, the two type of rectifiers are present, that is the center tapped and other one is the bridge type. So where to use center tapped, where to use bridge type, that depends upon the power level and the circuit in which they are to be used. So the rectification purposes are done in various applications. And lastly, we have studied about the different parameters which we have to study during the analysis of rectifiers, in which the important parameter is the peak value of the voltage, that is that too in the reverse direction, that is called as peak inverse voltage, PIV. We have studied about the PIV, that is the maximum voltage which can be applied across across the diode in the reverse bias condition. So it is a very important parameter. Next parameter which we have studied is the peak value of the current, because it decides the type of diode or the particular rating of the diode for which the rectifier will be designed. So if we are using a diode in a rectifier circuit, so the peak value of the circuit will decide the current rating of the diode. So for which current rating the diode will be used. So by this we will end this lecture, and in the coming lectures we will discuss more about the different type of rectifiers. Thank you.